Hi folks, Glenn here. I got another great question, and it is regarding the atomic theory and formulas WebAssign. I know that most of you have already turned this in, but if you were confused by this and you didn't ask for whatever reason, please pay attention here because this is going to show up on a future quiz or on the exams. So here you've got a bunch of atoms here, and they're saying we're going to make binary compounds, meaning compounds made of two elements or two kinds of atoms. And what are all the possibilities? Well, now remember that you got to have positive ions and negative ions because these are ionic compounds. Who are the positive ions? Well, they are usually the metals. Who's a metal? This guy is a metal, this guy is a metal, and this guy may be considered a metal or a metalloid. So let me show you the periodic table so you can get an idea of how to know what charge these guys are going to have, and so you can get an idea of how to know that these are in fact metals or metalloids. So let's see, ptable.com is a convenient periodic table to use, and that first one was barium. It's right here. Everything on the left side of this periodic table is a metal. All these yellow things, these pink things, these teal colored things, these are all metals, folks. See, aluminum, a familiar metal. Gallium, that's the last metal that we have in this particular problem. What was the middle metal? Yes, strontium. There it is, strontium. All these guys are metals, okay? The only non-metals here are these bright green guys, or I guess this is forest green guys, and then these sky blue guys. These are the non-metals, and they're the only non-metals in the whole universe. Weird, right? So let's get back to the charges. You're going to have to know that metals make the positive charges in an ionic compound. And how do you know what the charge is going to be? This is how you know, right there. 2, that's the charge. Barium is in the column number 2, so it has a 2 plus charge. Strontium is in column number 2, so it has a 2 plus charge. So for column number 1 and column number 2, it's very easy. You just look at the column number. All right? Now what about these guys? These metals, you cannot know the charge. Someone needs to tell you the charge, or you need to figure it out by what negative ions the thing is bonded to, because these things take different charges. If you remember from the podcast, episode 4, iron can sometimes take the 2 plus charge. Sometimes it can take the 3 plus charge. Your body prefers the 2 plus charge. Now, from a previous problem in WebAssign, copper can sometimes take the 1 plus charge. Sometimes it takes the 2 plus charge. 2 plus charge is prettier because it makes a greener or blue color. All right, now, what about these guys here? Aluminum, gallium, what charge do they take? Well, they're in group 13. They take the 3 plus charge. All right, so these guys take the 1 plus charge. These guys take the 2 plus charge. These guys, you cannot know just by memorization what charges these guys take. And these guys right here, these guys take the 3 plus charge. Okay? So we have the charges, so let's move this over. All right, so barium, the 2 plus charge. Who is the other guy? Yeah, strontium, the 2 plus charge, and gallium, the 3 plus charge. All right. Now, what about the nonmetals? The nonmetals here are oxygen and iodine. Oh, lucky us, there are only 2. So we're going to connect each, sorry, I keep switching. We're going to connect each of these metals with both nonmetals. Like, it's going to be barium with O, and then it's going to be barium with I. Right? It's going to be strontium with O. It's going to be strontium with I. See how I left a little space for myself? Clever, right? Ooh, sorry, a little late night humor there. Gallium with O, gallium with I. All right. Now, the oxygen, the O, right? What charge does that take? Very easy, folks. The oxygen is a non-metal. The non-metals prefer the negative charge. Why? Because you remember from one of these podcast episodes, I'm not sure if it was 3 or 4, but these guys all want to have 8 valence electrons or none. Actually, I may not have mentioned this rule of 8 valence electrons in the podcast yet, but I will soon. Okay, so to find the charge for oxygen, you just go 1, 2. It's 2 steps away from the end of the periodic table. That means its charge is going to be 2 minus. What about the iodine? 1. It's 1 step away from the end of the periodic table. So its charge is going to be I minus. It's going to be a 1 minus charge. All right? So let's go back here. So the oxygen was a 2 minus charge. The iodine was a 1 minus charge. 2 minus, 1 minus, 2 minus, 1 minus. Okay, so positive 2 and negative 2. If this charge is 2 plus, this charge is 2 minus, you can combine them just directly. Just one of these atoms and one of these atoms, and you'll have a 0 charge. That's what you want. The 0 charge makes a compound that would exist in real life. Okay? Ba2 plus and I minus. Well, there's only one negative charge. So you're going to need 2 of these to balance, to cancel out this 2 plus charge. All right? So that's going to give me Bai2. Does that make sense? This will exist in nature because it is a total charge of 0. So you do the same thing for strontium. It has the same charge as barium, so it's actually directly the same thing. What about these guys? How are you going to do this? There's no number of oxygen ions here that can add up to a 3 plus charge. Because oxygen's charge is an even number and 3 is an odd number, so this is not going to happen. What you can do is get a 6 plus charge. So if I put 2 of these, I'm going to get a 6 plus charge. If I put 3 of these, I'm going to get a 6 minus charge. So that's 2 atoms of gallium and 3 atoms of oxygen. Yes? So this is the formula. All right? Now, notice a little shortcut that materializes here if you look carefully. Let me change the color to green. Look at this 2. Look at this 2. Let me change the color to blue. Look at this 3. Look at this 3. Effectively, I mean, if you didn't feel like thinking about the arithmetic, you could have just written this 2 right there and written this 3 right there and came up with the same answer. Let's try it. Let's see. This is a negative sign, meaning 1 minus, right? So let me just write the 1 right there. Let me just write this 3 right there and see if I get the correct answer. Ga with a 1 and I with a 3. Now, anytime you have a 1, whether it's a charge or a subscript in chemistry, you can usually just leave that out because just the fact that I've written Ga here means that there is at least one of them, so I don't need to write 1. Okay, so GaI3. Is this correct? Let's see. Ga is a 3 plus charge. I is a 1 minus charge. And there are 3 of them. So 3 times negative 1 is negative 3. So this is a total of a 3 minus charge here. 3 minus perfectly balances out a 3 plus. I mean, it cancels out. So then you get a total charge of 0, which is what we wanted. So yeah, this is a valid shortcut most of the time. You can just put this number right there. Oops, sorry. You can just put this number right there and put this number right there. So that will get you SR2O2. You can put this number right there and put this number right there. That will get you SRI2. Were you paying attention closely? If you were, then you know that this is not quite correct. It should have looked like this. It should have been SRO, like BAO, you know? So what's up with that? Well, this is okay because, I mean, you can't just leave it like this, but this is not hard to simplify. There's a 2 here and a 2 here. So for every 2 atoms of oxygen, there are 2 atoms of strontium. I mean, you can just do that in your head. If for every 2 atoms of oxygen, there are 2 atoms of strontium, then it must be the case that for every 1 atom of strontium, there's 1 atom of oxygen. In other words, you can just reduce these the way you would reduce a fraction. You can just divide them by 2 each. So, in the future, suppose you had something like this. you wanted to combine these two ions into a compound, right? You can put this number here and that number there, so you would get Ni2O4. But see, you can divide these numbers by 2, so then you would reduce that to NiO2. Bringing back any pleasant or unpleasant memories of fractions when you were in middle school? For some of you, that was pleasant. For some of you, that is unpleasant. But for all of you, it's very useful. Yes, it's very useful to understand the chemical nature of things. Thanks. Bye.